This pilot is busy selecting current charts, and he has 3 different chart types that he will be looking for: the WAC, or World Aeronautical Chart, the Terminal Area Chart, and the Sectional Chart. Now, we are going to talk about each one and give you some guidelines for when to use the different charts. First, let's talk about sectionals. These are by far the most widely used, and these are the ones we have been looking at in the previous lessons. The scale on this chart is 1 to 500,000, which means that 1 inch on the chart equals 500,000 inches in real life, which is about 7 nautical miles. Sectional charts are revised approximately every 6 months when they become officially obsolete. So you always want to check the date on your charts and make sure the one you're using is current. Each sectional is named for a major city within the chart's area. It takes 37 charts to cover the conterminous U.S. Another chart you may use is the Terminal Area Chart. These are used around the country's busiest airports, which are surrounded by Class B airspace, like this one for Baltimore, Washington. The scale on this chart is 1 to 250,000, or 1 inch equals about 3.5 nautical miles. So it has much more detail than the sectional. This detail allows you to better locate the ground reference points and know your exact position. Terminal area charts have the same information on the front as the sectionals. They are also revised about every 6 months, like the sectionals. On the back of the terminal area chart, you'll find these things called VFR flyways and VFR corridors. These VFR flyways show the preferred routing in and around the Class B airspace. The VFR corridor is a VFR path, usually over the main airport, so that you don't have to fly clear around Class B airspace. Finally, the last VFR chart we will use is the World Aeronautical Chart, or WAC for short. The scale on these is 1 to 1 million, or 1 inch equals about 14 nautical miles. One WAC covers 4 times more area than a sectional and has much less detail. These charts are great to use when planning a long cross country. They are revised half as often as others, once a year. This is because they have less detail, and you would normally be flying at a higher altitude when using a WAC. So if someone put up a tall radio antenna here or there, it wouldn't be as much of a factor. Of the 3 types of charts, the WAC is the only one that does not show all the classes of airspace. The WACs only show Class B and Class C. Again, this is because the WACs have less detail. But even though the Class D airspace is not depicted, the airport symbol is still blue. On the back cover of each of these charts is a legend to help you identify the symbols. They also have a mileage scale here along the bottom of the chart. But remember, each minute of latitude is 1 nautical mile, and you can always use latitude to scale off distances. Now, another feature you'll find useful is the topography, which shows the MSL elevation of the terrain. Each of the charts uses a different standard in displaying elevation, which is indicated on the front cover. The sectionals use 500-foot increments, the WACs use 1,000-foot increments, and the terminal area charts don't really have a standard. It's just whatever the chart has on it, and that varies from chart to chart. On each chart, there could also be intermediate and auxiliary contours at various intervals, but these are only used when the elevation changes very gradually. To help identify contours, the charts are color-coded for different altitudes. And notice, here is the highest elevation for this chart. You can see that it's 11,499 feet, and they give the coordinates for that point right here. And critical and approximate elevation of terrain features are shown like this. Now, let's take a look at another chart and see what these look like. From the color coding, you can see that this area must be between 3,000 and 5,000 feet. And sure enough, You have the 5,000-foot contour line right there. This is an intermediate contour at 4,750 feet, and it says so right there. Over here, you see another contour line at 4,500 feet. And here is one of those critical elevations. Now, there is one more way to tell how high the terrain is in a certain area, and that is by looking at the maximum elevation figures, the MEFs. You'll find MEFs in the square that is formed by the latitude and the longitude lines. These squares, by the way, are called quadrangles. If you look in the center of this quadrangle, you will find the MEF, in this case, 79 for 7,900 feet. The way they get that number is by taking the highest point in that quadrangle, in this case, 7,560 feet. Then they round up to the next highest 100 feet, or 7,600 feet. Then they add 100 feet if the highest point is a man-made object, or 300 feet if it is a natural object, such as a hill or a butte in this case. So here they have added 300 feet to get 7,900. In this quadrangle, the highest elevation is a hill, but in another quadrangle, it could be the top of a tower or a building. So if you flew over any quadrangle at the MEF, you know that you would clear all the terrain and obstacles. But you would probably want to add some additional altitude for safety and altimeter errors. Now you know what each chart looks like and when to use it. You'll have fun going over them and dreaming up future destinations and interesting routes for cross countries. But there is one other thing that you need to know for sure, and that is charts won't do you any good at all unless you use them. So make sure they are current and take them with you whenever you fly.